Howdy, everybody. We're here for day 6 of Advent of Code 2015. Again, just doing some more problem solving, trying to get our problem solving muscles, the parts of our brains moving again, because at least mine has atrophied from doing, letting AI do half my work every day. And so, like I said, I really just enjoy solving puzzles. And so we're going to try and do it, see if we can't solve some problems to get us ready for the upcoming year. And I'd love for you to follow along. I've been getting some great comments. I'd love to see, how you solved it. Anything you could do to optimize mine would be fun and cool, or just did differently, right? Like I said, the previous days have been from a complexity issue less complex, and so there's lots of ways to solve it, and you don't have to have like the most efficient or coolest way to solve it to get the problem like quote unquote solved, right? So anyway, with all that being said, let's move on to day 6. Probably a fire hazard. Because your neighbors keep defeating you in the holiday housing decorating contest year after year, you've decided to deploy 1 million lights in a 1,000 by 1,000 grid. That's funny. We actually, there's a couple people in like nearby neighborhoods that do big light displays, and it's kind of fun to drive by them. But I can't imagine if it's like 2 in the morning and you've got red and green and white flashing lights going on that in your neighborhood, or even if you're that house, that may be annoying. But this is cool. So you have a bunch of, it's like you have a bunch of LEDs, right? A 1,000 by 1,000 lights, which is 1 million. Furthermore, because you've been especially nice this year, Santa has mailed you instructions on how to display the ideal lighting configuration. Lights in your grid are numbered from 0 to 999 in each direction. The lights at each corner are 00, 0999, 9999, and 9990. Okay, so we're the 00 is like right here, and we're going down this way, 999 to 999. The instructions, I mean, this is just to say we can use normal array addition and stuff to solve this. The instructions include whether to turn on, off, or toggle various inclusive ranges given as coordinate pairs. Each coordinate pair represents opposite corners of a rectangle, inclusive. A coordinate pair like 00 through 22 therefore refers to the digit 9 lights in a 3x3 square. Yes, okay. So it would include 00, 01, 02, 10, 11, 12, and 202122, right? Like that. Like that's what this is saying. So this is just standard for loop iteration, right? We've got standard arrays, and we're going to iterate over it through the thing. To defeat your neighbors this year, all you have to do is set up your lights by doing the instructions Santa sent you in order. For example, turn on 00 through 999 would turn on all. Toggle 00 through 990 would toggle the first line of 1,000 lights, right? So you're going down. 499 to 499, turn off 499, 99 to 500 would turn off the middle 4 lights. Yeah, okay. I did see the puzzle instructions. Notably, there's only 1,000. It's 1,000 by 1,000 grid, so there's only 1 million. I think we've had troubles in the past. I don't think it's this one because we only have 1 million, right? And it's very static. Like there's no, we've had, how do I say this? We've had problems in the past where we don't know the size of the grid. It's like an infinite grid. And then you get a bunch of these and they're huge numbers where you're turning on and off sections. And the way you had to solve it was to kind of like build overlaps of where you turn things on and where you turn things off. So like if you had this box on and then you turned this section off, you would like delete that section from this and from this section. And the best way to represent that was to like slice this section into like 3 boxes. If I remember right, it's been a while, but I think there was a way to solve that one. That was a way to solve one. I don't think that's this one though, because we're only dealing with 1,000,000. And million is something that most computers can do, even with these turn-offs and toggles, fairly easily, right? That being said, let's look at the puzzle. How many instructions are there? Yeah, there's only 300. So my guess is at least part one is more of a, what can I parse this? It's interesting that there's like toggle, turn off, turn on. Like I almost want to parse these. And then these are ranges. So maybe let's just start with some data structures first. So we'll say like nope, not let, struct point x u size, y u size, and we'll it just went out of my mind. What was I gonna do? We'll get there in a second. Okay, we have a input point. We could potentially use nom for this. I'm inclined to try not to use nom in solving these problems until it's sufficiently complex. Let's just see how it works without. I mean, this one's pretty easy, right? Presumably we have this string right here. And so we want to do like a what am I missing? I feel like I'm drawing a blank here. We want to like split off of am I missing? What am I missing here? I feel like, can I blame my cold? It is a split. Why doesn't it want to do? Why doesn't it like this? In Rust, a stir. Oh, okay, that was the problem. There we go. I was like, felt like I was going crazy. Like that. Okay, so we have a point. So we can parse these two now. And so we just have a struct. What do they call these? Instruction. So we'll have an enum. Turn on, turn off, toggle. It's going to be a little cheesy, but I think what we do, if we just say like if s dot starts with toggle, oops, turn on, I can do it like this too. We aren't doing any error checking here. We're doing a lot of assumptions, but same thing up here. Maybe we can work to fix that soon. So for the instruction, we have a instruction type, which is that, and then we have a start, which is a point, and an end, which is a point, and then we can do impl instruction, and we'll parse this. So how do we want to do this? I think first we want to determine what its type is. So we'll say let instruction type equal like that. And then we'll say let parts equal we'll split on white space. I'm probably doing these collects. I know a lot of people like to put this here. We can fix that later. So we can say let start end equal match instruction type. So turn off or turn on would be point parse 0, 1, 2. So the second, 3, 4, and the fourth. Otherwise, it's going to be the first and the third. Oh, oops. Like that. Sorry, I wasn't talking too much while I was doing that, but does this make sense? What I'm doing is like, first I'm going to parse the instruction type, which is going to look for toggle, turn on, or turn off. That's going to give me these pieces. And at that point, I'm going to know where the points are because they're different. If it's on a toggle, which is this one, I guess this doesn't have to be underscore. It's going to be at the first. So 0, 1, and third. And then turn off and on are actually going to be at the second and fourth. So I presume that works. I mean, let's just try it. So let instructions equal input dot lines dot. Oh, I think I can do like that. Oh, that's what I forgot to do. I was going to do something up here and I forgot. I don't know which of these I'm going to need, so I'm just going to do them all like a weirdo. I haven't actually looked. It's not clear to me that there's any harm in doing it that way, but because I think the Rust compiler just gets rid of it. So the last one is 222.12, 856, 241. And the first one is toggle 461, 550, 564, 900. Okay, so that does look right. Okay, presumably we can use that in all of our other stuff, right? So now we just have to implement this logic. We need to create a 1,000 by 1,000 grid, and we need to be able to turn them on, toggle them, or whatever. So maybe we just have bools. So we'll say let mute grid equals oh, am I doing this the wrong way? Oh no, and I did comment says semicolon. So we'll start with the grid with all of them off. And then we'll just go through the instructions and Okay, so we'll say like for instruction in instructions, and then we'll say like for x in instruction.start.x to instruction.x, and then we do the same thing for y's. And then we do match instruction dot instruction type. So turn off, we would say grid xy is false, and turn on, we'd say grid x equals true. It would be grid x y equals not. What doesn't it like about this? Oh, I'm missing one. How many lights are lit? Okay, so then the solution just is grid.iter flatten dot something like that. Why doesn't it like this? No method count found for option bool. Oh, it's not find, it's a filter. Like that. I mean, I think that's it. There's not really an easy way to test this. But okay, so we parse the instructions. Then for each instruction, we just go from the X to the Y. These are technically reversed if you look at how the grid is, but because it's the same size, it doesn't matter. Like, if you want to be strict, it would look like this. But again, it's 6 of one, half dozen of another. Let's just see if it works. We got it. That's the right answer. Okay. Again, I think the hardest part here is probably the parsing. I don't know if I want to spend a bunch of time trying to do it in nom, especially without the AI assisting me. I'm not familiar with enough with nom, but you could potentially have nom do this stuff. I don't know that it would be simpler, smaller though, but it would have error handling. So there's an argument like that's where it's helpful, is you can do the error handling part of it. So, but otherwise, then once you just go through it, you just loop through it. Oh, I still didn't add the this timing. Let's see what the timing looks like. Yeah, I mean, that's just not long, right? It takes 9 milliseconds to solve it. Unless part 2 is like substantially harder, I don't see why you'd ever try and do anything different. But let's see. You just finished implementing your winning light pattern when you realize you mistranslated Santa's message from the ancient Nordic Elvish. The light grid you bought actually has individual brightness controls. Each light can have a brightness of 0 or more. The lights all start at 0. The phrase turn on actually means increase it. Turn off means decrease, I presume. Yeah. To a minimum of 0. So you can't go negative. The phrase toggle actually means that you should increase the brightness by 2. So +1, +2, -1. What is the total brightness of the lights? Yeah, so this doesn't change much. It just changes like the inner logic. Like we can literally copy and paste our part 1 solution. Does this work? Yeah, it looks like it. I just didn't do it very well. Okay, so this is actually going to be 0. And we're just going to go through them. And if it's turn off, we're going to do we'll make these all U size, because I think we can do like a saturating sub. Yeah, it's not showing any examples, but like this will help us. I don't know why it won't show any examples. Saturating the numeric bounds instead of overflowing, right? Like it won't ever go below 0. And then this is just plus equals 1. And this is plus equals 2. Yeah, so just to be clear what's happening here, again, it says turn off decreases the brightness by 1, but to a minimum of 0, right? So if we're ever at 0 and we try and subtract, we want to stay at 0, and that's what the saturating sub does. I'm pretty sure. But then just, I mean, is this even easier? In this case, we just want to do the sum. Oh, it's a U size. So we just take the grid, we flatten it, and then sum it. I mean, I think that's it. Slightly longer, but not too bad. That's the right answer. There you go. Okay, there's day 6. Again, I don't think there's too much to this one. I'd be interested to see how you did it differently. Because in the end, you're counting, like the overlapping stuff that I talked about in the beginning, I don't know that's going to help that much. And again, the size is small, right? It's just 1,000 by 1,000, a million. Like, and even let's say for all 300, it asks you to mutate every single million. That's like what? So what is that? 300 million operations. That's still not a lot. I mean, it does get a lot. It does start feeling like a lot, but it doesn't feel like a ton. I don't know why. I guess what I'm saying is there's definitely an argument to be made that not the parsing part of it, but the actual like looping logic of it could potentially be an issue for really large values. But I mean, we're at 8 and 15 milliseconds, right? I think even if you added like 10 times as many of these, you're still only in like the 100 millisecond range for this one and the 150 millisecond range for this one. It just doesn't feel like a ton. So I don't know that there's optimizations. And this is actually, again, I think I've talked about this before, but you ask yourself, is this a solution that I could present to someone and it would be clear to them what the solution is, like without going too far into reading, grokking exactly what's going on. The parsing part, I think you could argue could be cleaned up, right? Some of this doesn't seem great. But the actual solution of the problem is literally just go through each instruction. For each instruction, go through all their positions and toggle them. Again, the Y and X being switched is just because if you think about the dimensions of an array, the first dimension is like what row it is, and then the second dimension is like what column it is. So it's like it's the opposite. Y is down, X is the other way. Again, we're using, it's not strictly to a graph, so I mean it probably doesn't matter, but as long as you're using the same Y and the same X in these ways, then you're okay. Yeah, okay. I mean, I guess there's not much to say about this, although I'd love to see, how do you solve the problem? What is your solution to it? What did you do differently? Maybe you did use nom or some other parser. There's potentially ways to make this simpler. So I'd love to see those. I think I'm just going to kind of leave this how it is, so you can see how my original solution was. This part right here, like this chunk, definitely feels like nom would help here, because if you think of like what a normal parser would do, is it would look for the toggle turn on, turn off, and then the rest of the string is going to start like right here, you would presume, right? And so you're always at that position, so you could always just say the next one is the start, skip this one, and the next one is the end, and that would be the case for all of these. In here I had to do this little trick where I said, oh, the start and ends are different, so I had to like put them in different places. So there you go. Again, hope you're doing well wherever, whenever you are, and I truly mean that. I want the best for everyone, so hopefully these videos giving you some insight and or giving you some ideas, or you found some better ways to do this. I'd love to see all of that. Anyway, we'll talk to you next time.